Good evening, everyone. Before I take my pleasure to introduce our tonight's guest speaker, please allow me to publicly my gratitude to IEEE section in Albuquerque for all of their support to restart this IEEE Women in Engineering Affinity group. And this evening, I am Khandakar Nusrat representing as a Women in Engineering Affinity group chair. I actually do not need to tell a whole story, but as an overview, IEEE Women in Engineering is one of the largest international professional organizations dedicated to promoting women engineers and scientists and inspiring girls around the world to follow their academic interests to a career in engineering. I hope we can make impact to achieve this goal by one of these monthly IEEE Women in Engineering talk where we invite speakers to share their experiences and stories. Well, our tonight's speaker is an electrical engineer who currently works as a senior member of technical staff on a variety of research and development projects, mostly centered around pulsed power and RF generation. She is a committee member and secretary of the IEEE Pulsed Power Science and Technology, Nuclear and Plasma Science Society, and is serving on the committee for the Pulsed Power Conference in 2021. Ms. Schrock will be discussing her experiences as a woman in engineering. Please join me virtually welcoming Ms. Schrock. Couple of things to announce. Please use chat window to type any questions, comments, suggestions you have. And you are most welcome to unmute yourself if you want to ask any questions. Now let me share my screen. Okay, I hope you can see.
Yes, perfect. So thank you for the introduction. My name is Emily Schrock. I'm a senior member of technical staff at Sandia National Labs as a research and development RF engineer. So I'm presenting today, I called it a day in the life being a woman in electrical engineering. So I'll kind of go through Sandia and then kind of my day-to-day, what I do, my research that I work on, and then I'll go kind of lastly into being a woman in electrical engineering. You can go on to the next slide.
Okay.
So to give a little bit of background about me, so for my education, I got my Bachelor's of Science and my Master's of Science in Electrical Engineering in 2016 and 2017 at Texas Tech University. I worked in their Center for Pulse Power and Power Electronics, or they also call it the P3E laboratory at Texas Tech during my undergraduate and during my graduate time, mostly working on my master's thesis. So that was testing and a failure analysis of wide bandgap semiconductors for pulse power applications. So started out in pulse power and my career has continued in the pulse power field at Sandia as well. For work history, I started internships back when I was an undergraduate in 2014. I had my first internship at Texas Instruments. I was actually a software engineer writing in C in their battery management group. And then in my second internship at Texas Instruments, I was designated a test engineer. So I was working in the LabVIEW code in order to manipulate hardware and code hardware to do testing on different power supplies in the power supply group at Texas Instruments. And then I already mentioned I worked in the P3E laboratory, the Center for Pulse Power and Power Electronics laboratory at Texas Tech, doing my master's thesis work. And then after I graduated with my master's, I came here to Sandia National Labs in Albuquerque in 2017, and I've been working there for almost 4 years now. So just kind of a couple of personal things about me. I have 2 German Shepherds, one's 4.5 and the other one is 5.5. So I got the first one in grad school. And I will be married 3 years this April to my husband, James. We have a baby boy who is about 9 months old now. He was born last April. And I was born and raised in Texas until about 2017, when my husband was stationed here at Kirtland Air Force Base as active duty military, and I started working at Sandia. For hobbies, I like running, hiking, camping, traveling, photography. I love doing art. So Albuquerque is actually an amazing place for us to have landed, and we both actually really love it here. Next slide, please. So being from Sandia, I wanted to give a brief overview of Sandia National Labs. Some of you might be extremely familiar with Sandia, and others of you might not really know the breadth of what Sandia does.
Sorry.
No, it's okay. So Sandia National Labs was established in 1949 from the Z Division, which was actually created by Los Alamos in 1945. So our roots trace back to the Manhattan Project and then Los Alamos as well. We are a federally funded research and development center. And so we operate a little bit different from industry in that we're long-term strategic partners to the federal government. We operate in the public interest with objectivity and independence, and we maintain core competencies in missions of national significance. So we work with government partners called sponsors, and we assist in research and development and the study and analysis of systems, as well as doing engineering and integration with those systems as well. Our main location is here in Albuquerque. We have another location, a small location in Livermore, California, near Lawrence Livermore National Laboratory as well. And those are kind of our two main locations. We have a slew of other testing locations around the globe, but for work locations, it's Albuquerque and Livermore. On the bottom left, I show a figure that has the 5 major program portfolios. I'll start at the top and work my way around clockwise. So nuclear deterrence, that program portfolio is where we maintain the current US nuclear weapons stockpile, and we sustain that stockpile into the future. For the next one, global security, that's really focusing on protecting the nation from strategic and weapons of mass destruction threats at home and abroad by developing and deploying solutions and expertise to monitor and assess threats. The next one down is the National Security Program portfolio. So this is providing the systems, science, technology, and expertise in support of national security. So some examples of that would be ensuring the security of critical networks, looking at target acquisition, and then research and development of defeat technology and military systems and technology as well. The next one I have there is energy and homeland security. So they're doing fundamental and applied research and development to support the resilience and security of the nation's energy system, and then doing protection for critical infrastructure as well. And then finally, we have our advanced science and technology program portfolio, which is fundamental science and engineering capabilities to ensure the nation's nuclear stockpile is safe, secure, and effective. They do leading research in fundamental science to promote national security and maintain international scientific leadership. Some examples of that would be nanotechnology, geoscience, they do fusion research, and then you might have heard of the Z machine, which is used to do radiation effects and high energy density science. On the middle image there, I have the FY20 budget, just to give you kind of an idea of the budget at the National Lab. So we topped $3.9 billion in FY20. The majority of that went to the NNSA weapons, or National Nuclear Security Administration weapons. So that's our nuclear weapons division. The next one is other DoD work. And so we do research and development for both DOE and DoD, and that kind of shows in all of the budget from FY20. And then I did want to also point out that Sandia has about 14,000 employees. It's up about 5,000 from 2009. So the workforce has been growing in order to be able to effectively work on everything we're currently doing. So we have about 12,000 people in New Mexico, and then about 1,600 in the California site as a smaller site. And next slide, please.
Okay.
And then this is just kind of to show, so back in 1949, when Sandia became a national laboratory, Truman sent a letter to the AT&T president encouraging AT&T to accept management of Sandia. So as an FFRDC, we have a management company. And it captured the ethos of Sandia that's still relevant today. And it's part of, you know, kind of the saying around Sandia. So it says, in my opinion, you have here an opportunity to render an exceptional service in the national interest. And that exceptional service in the national interest is something that has been carried through now at Sandia National Labs. There's just an amazing amount of science and engineering that's done here at Sandia, not only in the nuclear weapons division, but that spans all kinds of technology. So I've got some examples here. For example, parachute technology that was designed for nuclear weapons helped the Pathfinder spacecraft land on the surface of Mars. A synthetic aperture radar system has saved the lives of countless servicemen and women by detecting IEDs from unmanned aerial vehicles. And then you can see others here doing hydrogen fueling systems in Sandia's transportation energy research that provides gas boosting for nuclear weapons, and so on. You can talk forever about all of the amazing technology that has come out of Sandia. So if you want to move on to the next slide, that's the last slide I have for overview of Sandia National Labs. So I can pause here if anybody has questions about kind of Sandia's infrastructure or the layout of Sandia. Okay, I'm not seeing anything in the chat window, but
yeah, I also do not see any questions in the chat window. No, I just checked out, so I think we are good. Yeah.
Okay. Well, if anybody has any questions at the end of the presentation, please feel free to speak up then too. So next, I'm going to go kind of into what I do at Sandia and kind of the typical day-to-day as a senior staff member, kind of what that entails. And so my main projects that I work on all center around pulse power. I work on looking at compact pulse power specifically, so getting a high amount of energy out of systems in very small packages, and looking at both of the components in order to make that happen, as well as the full-on systems and how to integrate these systems into a small enough package. I'm specifically looking at compact pulse power for driving RF generation and high power microwave loads. So high power microwave being the RF frequencies that we're looking at, and high power being, a high power versus kind of low power RF, for example, cell phones or something like that. So high power microwaves looking, up to the gigawatt class type of high power microwave loads. And then just to kind of give you an idea of what this RF generation chain looks like, I've got an image here on the left that starts with prime power. So the easiest example for this is thinking about your wall plug power. 120 volt, 60 hertz AC can only provide so much average power. And so you take something that can provide low average powers and charge up into energy storage over a long period of time. And then you also included in that pulse power, you do pulse conditioning in order to have extremely high peak powers and extremely short time durations. So you start with these long time durations, low average power, and then into the load, you can provide extremely high peak powers and extremely small time scales. So we're talking, you know, times 10 to the -9, times 10 to the -6, nanoseconds, microseconds, that kind of extremely short time frame that, that we're delivering power to the load. And then for research and development components, so not only do I look at the full pulse power system as a whole, I focus in on the components as well. So I do research in understanding innovative materials and assemblies of these different components. So for capacitors, for example, looking at new materials in order to increase what's called the energy density of capacitors. So how much energy this capacitor can store in its volume. So energy per cubic meter that's capable of being stored in a capacitor is one thing that I do research in. Doing research in switches, it's a major component of pulse power systems, as well as the trigger generators that that switch the switches themselves, and then looking at different prime power examples. So if you don't have access to wall plug power, looking at thermal batteries, looking at ultracapacitor banks, things like that, in order to have a big bank of prime power that you can pull from. And then I also put an example here of a pulse power system. So this is a Marx generator. You have positive and negative input voltage on the left-hand side, and then you store energy in the energy storage components, which are the capacitors in this configuration. So we've got 4 capacitors here, and then we've got switches, which are the components. I don't know if you can point at them, if you know what they are. I can't point at them, but anyway, switches that go between those capacitors. Yeah, thank you. And that's part of the pulse conditioning of the Marx generator. So the way that these are laid out allows for extremely high peak powers in short time scales into the load. And then I wanted to point out that I specifically collaborate with UNM on these projects. We have 2 interns and multiple students at UNM that currently work on these programs with me. And then kind of just to talk about day-to-day what I do. So on a typical day, I'm doing laboratory testing of the components that I mentioned, as well as the full system. I'm also doing research, like I said, into the new materials, component design for capacitors, switches. I'm also doing circuit analysis and modeling. So here I've got a pretty picture, but I've got very detailed circuit models in SPICE simulations that I can use to predict what's going to happen with these systems, as well as doing other types of modeling, for example, in COMSOL or CST or something like that, in order to understand kind of electric fields and other aspects of the system as a whole. As a senior member of technical staff, I also work heavily in the project management side. And so I do proposal writing, report writing, budgeting for my projects. I lead project direction. I attend conferences. I work on journals and publications. I do presentations. And so all of that kind of is part of engineering. And if you want to be able to do the research that you're really interested in, then that is what enables it to happen, is all of the project management behind it. And we can go on to the next slide. And I've got one more that talks about kind of what I do at Sandia. So I also work in nonlinear transmission lines. It's also called Nltls. So typically high power RF generation is done with vacuum tube sources. And nonlinear transmission lines are a research avenue that's being studied right now into solid state RF generation. So getting rid of the complexity of having a vacuum tube and also removing the X-ray hazards that are inherently associated with these vacuum tube sources. So I'm specifically looking at something called a synchronous wave Nltl. There are different names for different Nltls depending on the configuration that you choose. And so this one is specifically a synchronous wave. It utilizes the nonlinearity in the inductors. And then there's a dispersive nature of this LC network, and those two work together in order to generate RF pulses. So I also do research in nonlinear transmission lines. You can see a schematic if you're interested. And then that schematic has an inherent dispersive nature or dispersion relation that I've got as a formula there. So just to kind of show you kind of the more mathematical side of what I do too. And then finally, I work a lot in photoconductive semiconductor switches, or PCSS. So these are laser triggered. We're working on getting them to high voltages. We've tested them up to 60 kV, and they're semiconductor switches. So they kind of tie back into my thesis work of doing semiconductor switches for pulse power applications. These switches are very desirable because they can have extremely fast switching times, and then there's that inherent isolation of having it be a laser triggered switch. And this is another example of a project that we're working with Dr. Jane Lear in the ECE department at UNM on this project. She's collaborating with us on this. And I've got an image of a PCSS there. So we're using gallium nitride as the semiconductor, and we have current conduction between the anode and the cathode sitting on the top of the device. And then an optical trigger is what actually triggers the device to turn on and current to flow. And then on the right of that, you can see the PCSS device images. Yeah, thank you. So there's the anode and cathode that you can see with the bond ribbons attached on top and bottom. And then the right is actually a switching event. So this is kind of one of the interesting things about these devices is that when you test them in a certain, in high voltage configurations, you can get current filamentation rather than having uniform current densities. So it's something that we're interested in and looking at heavily. So I think that's the last slide that I have for my work at Sandia. Oh, I did want to take this opportunity here after I've talked about my work and encourage those of you who are undergraduate students or graduate students already to keep pursuing or pursue your master's or PhD. I have found in my experience being an electrical engineer that having a master's or a PhD really helps you do the research that you want to do. You can really define your project direction a little bit better than if you just have a bachelor's. And you also get paid more, which is always a plus. You know, you start out with a higher salary, and so as you move up, you continue to build on that higher salary. And so it's definitely something that I encourage everybody to do, to at least get a master's and to work on a PhD. I currently have a master's, and I'm slowly working on getting a PhD. I have one more class, and then I have to do all of the research behind it. But I definitely encourage that of everyone. So I can pause here for a few moments to see if anybody has any questions about the work that I do at Sandia.
Actually, yes. I got a message. So it's from John Pace, and he's asking, are your Nltls using saturable inductors? If so, what material? Is it saturable? Yeah, did you get the question?
Yes, yes. Yeah, so our inductors do have saturable cores, and I can't remember the material off the top of my head. I think one of the versions that I've done multiple versions. I've had just a board top version that I've done at very low voltages. And that one was just used ferrite cores, if I remember correctly. So you can change the parameters of the core and change the parameters of your inductor and get to different frequencies, inherent frequencies of RF generation.
Are there any questions? You can also ask directly. I believe the settings are, you can unmute yourself. I think someone is talking background. Okay, no, I don't see any more questions here.
Great. Well, like I said last time, if you come up with any other questions, feel free to ask at the end. And we can move on to the next slide.
Oh, I don't know, my mouse, sometimes I have no idea. I was trying to, okay, there you go.
It's all good, thank you. Yeah, so now I'm transitioning into kind of being a woman in engineering. So kind of going from, the work that I do to kind of how being a woman in a male dominated field, and that experience has been for me. And so in the abstract that was sent out, it included kind of this first portion of it. So when I graduated with my bachelor's at Texas Tech, there were actually 17% of my graduating class were women, which seems kind of high, actually. We had 5 women in a graduating class of, I think, 23 or 24. And so I had a support system of women around me. I mean, we all went through our bachelor's together. And I went from having, 5 women around me to having kind of varying numbers of women around me in my different jobs, just kind of depending on where I worked, depending on what field I was working in. It kind of varied on the number of women, but I'd say between 10 to 17% was probably the most number that I've had around me kind of on a day-to-day basis. And one of the things that I wanted to point out is, as I went into my career field, compact pulse power is quite niche. I mean, there's not many people doing this in general. And the applications I work in, RF generation, high power microwaves, is also quite niche. And so that, I think, as well as being, women being a minority in engineering fields, that led to me being one of very few women in my work. So, for example, when I came to Sandia and did my interview with my manager at the time, he told me when we came out to the area where I would work full time, that I was the first woman to be working out there full time in this pulse power laboratory, which is where I still work, in over 3 decades. So it was an 8-person office, grant you. It wasn't a very large office. So if there had been another woman that was working there at the same time as me, then we'd be great on our numbers of percentage of women working there. But so that was just kind of something that I thought was funny that he said to me that kind of stuck with me. That I was the first woman to work there full time in over 3 decades. And not to say that the people I worked with hadn't worked with a woman in over 3 decades. It was, there were people that had just started there a year ago. But it was kind of an interesting fact. And so even to say that, I mean, I've had amazing support as a woman in engineering. And so really what I'm here today to do is to talk about what I think has made my experience so great, and why I think I've had so much support, and why I've been so successful in this field. And so things that I wanted to touch on, and I'll touch on a little bit more later, is the support that I've had from my coworkers, from my management team and from team members, so both internal and external team members on all of my projects. There's just been an amazing amount of support, you know, from all of them. And so having that support has been extremely useful to me as a woman in engineering. And then I also wanted to highlight joining and my involvement in diversity and inclusion groups. So I'll touch on this again on the next slide, but you know, as I've been in my different jobs, I've joined and gotten involved in the women's groups that I've found. And I think that has really helped, again, the support that I have as a woman in engineering. And then finally, as was introduced, I am involved in my professional community. So I'm a committee member of the IEEE Pulse Power Science and Technology Committee, along with other female leaders. So we are helping to lead the direction of that committee. And we work on different conferences and things like that. And it's really great to have female leadership in those kinds of committees in order to make sure that we're being represented as a group as we move forward. I think you can go on to the next slide. I think that's all I have. So I kind of turned this around, and initially I talked about what I thought, you know, helped me as a woman in engineering. And so these are things that I want you to look for in your job, as you know, for those of you who are getting your undergraduate or graduate degrees, as you're moving into the career field, there are things that I hope that you look for and can help create as you move into those roles. And so looking for supportive management and coworkers. I mean, whether you're a man or a woman or whatever job you have, you want to make sure that you're going into a job where you're going to have supportive management and coworkers. This is especially true for women in engineering, as we are more of a minority in this field. And so having that support from your management and your coworkers is extremely, extremely valuable. Again, I touch on diversity and inclusion in your company, not just having the resources available, but also that there is diversity and inclusion that you see in your job around you. And then finally, I touch on networking capabilities to connect to and support other women. So for example, Sandia has the Sandia Women's Action Network, which I'm a member of, or I join their talks and their networking opportunities and things like that to connect to other women. And then the Sandia Parents Group, which isn't specifically for women, it's for parents, but has specific resources available for women as well. And then there are many other different networking capabilities that you can have to connect to and support other women. And then I have a bullet point here that says, if there isn't anything available, create it. And so this kind of brings me into a story that I have, and it brings me into the side note at the bottom of the page. So the meaning of being a woman in my field changed whenever I became a new mom in the engineering field. So when I became a mom, I decided that I wanted to breastfeed my son until he was a year old. And in doing so, by making that decision, I also inherently decided that I would have to pump at work, which is, obviously not something that any of my 8-member male coworkers have ever had to do. And so I had to go out and find the support that I needed in order to succeed in my goals of wanting to breastfeed my son until he was a year old. And so I created a nursing mother support group at Sandia under the Sandia Parents Group, and they've been extremely, extremely valuable resources to me while I've been creating this. But I created this nursing mother support group. We meet once a month, and we talk about, you know, pumping at work and the issues that we're having and the resources that are available at Sandia. And it's just really an awesome community that we've been able to create. And so this also kind of goes into advocating for yourself. And so, you know, there wasn't, and what I needed wasn't available. And so I advocated to the Sandia Parents Group that we needed this capability, and advocated that that was something that needed to be spun up. They were extremely, extremely supportive of my decision, and you know, it's been going extremely well. And so if there isn't something available that you need as a woman in engineering, I extremely hope that you advocate for yourself and make sure that you get what you need. And then additionally to that, I want to touch on setting realistic expectations and boundaries for yourself. So when I became a new mom, I was getting ready to return to work after my maternity leave, and remember thinking to myself, you know, I don't want to become a stereotype of a woman who works full time and also takes care of my son as kind of the main caretaker. You hear that a lot in the news, or you know, in different articles, that, you know, women, even women that are working, you kind of end up being that main caretaker. And I have an amazing husband. I'm not saying anything bad about him. He has been extremely supportive, but I did sit down with him and I said, you know, we need to set boundaries. I need to, you know, make sure I can get into work at this time. I need to make sure I can get home by this time. I can work until this time. And so we are very collaborative in our schedules and make sure that we are always thinking of the other person when we're scheduling a meeting, like a late meeting, or we're having to do work on the weekends or something like that. So that goes to say, set realistic expectations and boundaries for yourself. I definitely learned that as a new mom in this field. And that also goes again to advocating for yourself. And we can go to the next slide.
So Emily, can you check your chat window? I think you got
Sure.
3 questions. Okay, thank you.
Yeah. I think I'm going to go ahead and answer those at the end. I just have one more slide and then my conclusion slide.
Oh, sure, definitely, yes, definitely. Okay. Okay, there you go. Okay, so this slide is really to highlight something that I have done myself, and that I know other people are doing because I've seen it around me, happening to me or around me for the last 4 to 5 years that I've been in the electrical engineering field. So I've got 2 scenarios here. We'll go through the first one first. So it's 2 people discussing a project that has just started up, and this is based on something I almost did last week. So first person says, I have a coworker who would be perfect to work on that. Second person, great, what's his information? First person says, well, her name is, and so, like I said, this is something I accidentally almost did last week. I was emailing with someone, I have a project that's starting up, and they told me the name of the person who'd be working on it, and I didn't know whether that was a man or a woman. I almost replied asking for his information, and it turned out that it was a woman. Thankfully, I had reworded my sentence to say what's their information, because I realized in the moment that I didn't actually know, and that I had implicitly assumed that the person on this project was going to be a man. And so there's a habit I found. Like I said, I do it, and I know other people do it. Males and females do it. In male-dominated fields, we do it. For
female dominated fields, we do it all the time where, you know, unknown people are referred to as whatever the dominant gender is. So in engineering, these unknown people are referred to typically as male. And I really encourage all of you to take a second when you're in this kind of situation where you don't actually know who you're talking about, and make sure that you're using, you know, nouns that don't specify gender, you know, what's their information, things like that. So it's just something that emphasizes that women are working in a male dominated field, and people assume that there are males that are, that it's more likely to be a male. And then the second scenario I have is a meeting, mostly males, maybe one, maybe two women in attendance. The male leading the meeting says, "All right, that wraps up the meeting. Thank you all for your inputs. Have a great day, gentlemen." Looks over, realizes there's a woman in the meeting, and goes, "And ladies." And this is something that's happened to me countless times. I've been the only or one of a couple of women in a meeting where we get singled out at the end for being one of only a few women, and the person who was running the meeting had just assumed everybody was male. I mean, I bring this up just because it, again, just highlights the fact that, you know, women are minorities in this male dominated field of engineering. And I encourage you all to change that habit, to refer to people who are unknown with something that doesn't specify gender, what's their information. And then if you're in a room full of males and females, or even in a room full of people you don't know how many are in the meeting, use something everyone, you know, something that doesn't specify gender. So just kind of something that I've picked up over the last couple of years that I've noticed, and wanted to share with everybody in case you hadn't had this happen to you yet, or you hadn't realized that this was something that people do. So if we go to the next slide, this is just the conclusion slide. So like I said, I've had amazing support as a woman in a male dominated field, and my experience has been great. I've found that in my career, the majority of people are interested in the results and accomplishments that you have, regardless of your gender. So the success that I have and the success of the team is above all to, you know, who is working on the team. And I encourage you to find teams that are like that, because having the support of your team like that is just makes the experience so great. There are still improvements we can make to help diversity and inclusion of women in male-dominated fields. So I encourage you to advocate for yourself. Men, I encourage you to advocate for your coworkers. I encourage you all to join diversity groups, inclusion groups, and get involved in them where you can. And then take advantage of the resources available and help create the resources that you need if they aren't available. So, you know, advocate for yourself again. And then go to graduate school, get a master's or a PhD, especially if you're considering a job in research or where you want to pursue your own interests or research. And then get involved in your professional community to help lead the direction at that level as well. That is the end of my talk, and I appreciate you all for listening in. And we've got about 15 minutes for questions, so I can go through the chat window first and answer those. And then if anybody has questions besides that, you can also, you can also email me if you have any specific questions after this. I don't think it's actually in my presentation, and I don't remember if it was on the flyer either, but we can throw it up. Okay, I'll go into questions. So the first question we have is, besides your technical training and expertise, what types of